So in this video, we're going to talk a little bit about, we're going to introduce exponential equations or functions, and we're going to compare them just so you can see the difference between linear equations, quadratic equations, and then exponential equations. Okay, so let's get right into it. You remember that linear equations basically produce straight lines, don't they? And they follow the form y is equal to mx plus b. That's called the slope-intercept form of a standard equation, right? And I'm purposely choosing the slope-intercept form because I want to contrast it to these other forms that also use y on one side. Now, the feature, again, of a linear equation is that it produces a straight line. And the other feature that you want to consider here is that the degree of this equation is 1. Now, what does that mean? Basically, the largest exponent that you have in a linear equation is on the x, and the exponent is a positive 1, okay? When you see that, you know that you're going to get just a straight line. When the largest degree is 1, it means you're going to have some kind of a straight line produced from this equation, okay? Now, quadratic equation, again, briefly, remember, follows the form y is equal to ax squared plus bx plus c. And you really, the bx plus c is not necessarily used, but it will produce, all you need is really the y is equal to ax squared. And again, you'll notice that the exponent now has increased to 2. Whenever you have a degree, or the largest exponent is 2, right, you're going to produce a curved line. You're going to produce a parabola. Okay? Parabola. Now, those are all well and good. Now we're going to contrast it, though, with the exponential equations. And this is really where the introduction comes in. The standard form for an exponential equation is y is equal to a, some number, to the x. Okay, so the exponent is now the variable x. Okay, the exponent is the variable. In the linear equation, the degree was 1. We know that it produces a straight line. In a quadratic equation, the degree was 2. We know it produces a parabola. But in an exponential equation, the variable is what's changing numbers. And let's see what that looks like. Probably the easiest way to do one of these is to produce an xy table like we have done in the past, okay? And let me show you how this works. Now, the a is just some kind of a number, some kind of a coefficient, so we need to choose a number there. Let's just choose something simple. Let's just say y is equal to 2 to the x, okay? And what we're going to do is we're going to introduce some kind of an x, all right, as our input, and we'll see what kind of a y we produce, and then we'll graph it. So here's our x, y-axis. And we'll just go ahead and do some of these quick sketches just so you can get some idea, okay? Now, let's assume, normally it's a good idea to choose positive numbers, 0, and negative numbers whenever you're introducing some kind of a table like this, just so you can see what it looks like on both sides of the axes, okay? So let's start with 1. Let's assume that our x is 1. If we put 1 through here, we'd have 2 to the first power, right? And 2 to the first power is equal to 2. So y would be equal to 2. Therefore, 1, 1, 2. There's our first point. Let's put in 2 for x. So 2 squared would be 4. Therefore, y is equal to 4. So 1, 2, 1, 2, 3, 4. You can see it's starting to climb pretty quickly. It's starting to look almost like a parabola, but it's going to change rapidly here. Let's put in 3 for our x. 2 to the third is 8, right? So y is equal to 8. So now I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And you can see what's starting to happen. The curve is really getting to be kind of steep at this point. And if I put in 4 here for x, y would be 16, be way the heck up here. So let's choose our 0 now, just for the heck of it. If y is 0, or if x is 0 rather, our input is 0, I get 2 to the 0. Now remember that any number to the 0 exponent, or to the 0 power, is always equal to 1. So now I have, as my ordered pairs, 0, 1. Okay, so now those are our positive, and those are our positives and zeros. Now let's try some negatives. Let's try negative 1. If I put y is equal to 2 to the negative 1, remember that a negative 1 is not a negative number. It just says put me in the denominator. So it's going to be y is equal to 1 over 2 to the first, which is just 1/2. So if my x is negative 1, my y is positive 1/2. So x is negative 1, y is a positive half. Okay, if I put in x is negative 2, 2 to the negative 2, turns out to be y is equal to 2. Whoops, excuse me. Actually, let me change that real quickly. Y would be equal to 1 over 2 squared, right? And 1 over 2 squared is 1 over to the 4. So actually it's a 1, 2 for my x, 1/4 for my y. Look what's happening. And you can kind of predict I'll never reach 0. I'll just get a smaller and smaller fraction. I'll get 1 over 8, or 2 to the third, or 1 over 8, which is way, way down here. Look what kind of a line this produces. This is called an exponential equation. There we go. This line here, which will get closer and closer to the x-axis, right? But will never quite reach it. That boundary is called an asymptote. So think of an asymptote as a boundary, all right, from which your line, your graph, will approach, but will never quite touch, all right? And then this one obviously just going to grow really, really large here. Okay, so that's what you call an exponential equation. That's the difference. Hope that was helpful.